This conference will now be recorded.
Okay. Okay. So as we said, we will have the white paper readiness by next week, or hopefully publish it by Friday. Experience Center, do you want to give quick update? Anything ready?
Yeah, real quick. Yeah, I think as I mentioned in the last meeting that we don't have space for 2 demos. There were total 10 demos plus 2 show and tell form factor demos. We need a space for 2 demos, and OCP essentially, accommodated extending the space by a few feet. That essentially means we can accommodate all the demos that are actually in the spreadsheet. They are actively working on the layout. I will share the layout once they actually provide those details, most likely going to be next week. So at this point, if you have a demo in the spreadsheet, then assume that your demo is accepted and start planning for, making sure that the demo works, and then the equipment and then shipping and all those things. That's the key thing. I also sent a note to the folks who are actually the demo owners. In general, what we did is there were few demos where they were the owners were asking for 2 monitors. There is only space for 1 monitor, primarily because in one table, we are actually hosting 2 demos. So make sure that you bring only 1 monitor, and it needs to be 27-inch or less. So that's a key thing. Wherever you have the power requirements, number of outlets, make sure that those details are accurate. The reason being, they will be handed over to the OCP, the team. And when you are ready to do the setup in the OCP Experience Center, you should avoid the surprises, that are going to actually, cause problems for you, for your demo. So ensure the power requirements and the number of outlets that you need are actually accurately captured. The last one, we have 10 passes for early setup. So I need the staff owner name for each one of the demos, which is actually in the column N. So only one staff, rep is allowed per demo. So please include that, and then I will hand it over to the OCP team. So with that, I think we are pretty much, kind of logged in on the plans for the Experience Center demos. Any questions?
Hey, Reddy, your email says handbook for the shipping instructions. Follow the instructions in the handbook. Will we get the handbook, or have you already sent it?
Yeah, it was already mailed out. I can actually send it again to the same, reply all. Let's see. I'll just take care of it right now, Nara, if you don't have it.
Cool.
Okay.
Cool, thanks.
Yeah, no worries. Any other questions?
So,
All right.
Reddy, this is Supriya. So, if we want internet, you said we have to buy separately, right, for the demo?
No, it will be Wi-Fi. The Wi-Fi will be shared. So the possibility of you getting a predictable, the bandwidth is probably not going to be there. So that's essentially what it boils down to. So you're basically sharing the Experience Center Wi-Fi.
Okay. Sorry, I just joined late. So, so we will have a table, 1 monitor, right? I mean, I don't have to order anything.
No,
or should I?
In the spreadsheet, there is essentially a placeholder that says the monitor size. In the parentheses, it says bring your own monitor or OCP. Pretty much, OCP doesn't have a whole lot of monitors. So unless you absolutely need it, there is no other way for you to bring your own monitor. Just indicate that in the spreadsheet. But the expectation is that you're bringing your own monitor.
Okay.
Okay.
And we can set it up that like October 16th afternoon, the demo, the whole
Yeah,
setup?
normally you will end up setting it up right, Monday, basically.
Okay.
That is
Is there
October
like a
16th.
timeline, like specific times that we need to show up there?
Yeah, take a look at the handbook. I don't recall exactly when you need to show up, but that handbook has details. If not, yeah, just respond to that entire email distribution list and add Kelly to it, and she'll be able to respond.
Okay.
Okay.
Awesome. By the way, I would like to really appreciate how much work this Reddy is pulling in. It's just amazing. I can't thank you enough, Reddy.
No worries. I'm just glad that we are able to accommodate all the demos. That was my key goal.
Yes, and we need to figure out how to get visibility for all this experience center. So anybody who is making presentations who are going to be in experience center, please make sure that in your presentations you have a call out and pointer to the experience center to come out and check. So please feel free to do that. And I think Reddy, we should figure out a way to create a blurb so that people can create it on LinkedIn.
Yeah, excellent idea. I think the presentation deadline for your final presentation to be uploaded in the FN Speaker portal is actually September 29th. Make sure that in the, towards the wrap up, you have essentially the links to the white papers and demos in the Experience Center booth. We will basically double check that when you submit the final presentation, but that's important to include that in your presentation material. Right, and then we also have 2 10-minute slots. We have to figure out what's the best way for us to, in the Experience Center, to cover the CMS demo content. That, me and Manoj will figure out what's the best way to ensure everything is covered in that 2 10-minute slots we get for CMS station.
Okay.
So that will be within that, obviously that will be within the conference, but before the conference, yeah, anything you guys can actually dial up and amplify through the LinkedIn and other marketing channels, that will be really appreciated.
So, sorry, Reddy, this 10-minute presentation, I know that we have like a 20-minute slots of CXL presentations. So this 10 minutes is a different thing?
Yeah, this is essentially for the demo show and tell kind of a thing for the CMS station. We haven't actually finalized when we want to lock in, but it is essentially, can have 2 sessions, 10 minutes each, or you can combine those 2 and make it 20 minutes. This is not for individual demo hours, just to be clear. This is for all the demos.
All the demos. And who will be like, I know there are keynotes, executive talks. Is it like one of those, like
No. It is in the Experience Center. You essentially have, there is a space in the Experience Center zone where you end up actually doing the talk.
Okay.
Okay. I think we need to give time to Pankaj.
Yes. Okay, let's do that now.
If you have any questions, yeah, send me a note offline.
All right. Thank you, Reddy. And Pankaj, floor is yours. Pankaj, are you mute? You may be on. Pankaj, you may be on mute.
Yeah.
How about this?
Oh, okay, perfect.
Yes, perfect.
Yeah, I was on mute on my phone. So, so very good. You guys see my slides, I think.
Yeah.
So plan is I'll do a very quick recap of where we were, and I'll do a quick update on what we have learned through discussions and what's changing, and then invite you to participate. So that's the plan for today. So as you remember, the initial proposal of Accelerator Programming Interface, which is a proposal to go halfway in this core design activity that we anticipate for CXL computational memory and related topics, is to have a way of programming accelerators while removing any parallelism offload restrictions that existed pre-CXL because devices could not talk to each other. So we created this very simple API with a simple theory of operations that I mentioned to you last time, is that you allocate infrastructure in the form of computational subsystems, you define data sets, and you execute service meshes on that computational subsystem against the data sets. Okay, so that's the and we had one example, simple example that I walked you through. So this was the way we inherit from Redfish, and during the meetings to review this, some really interesting questions came up, like NVIDIA wanted, can you model DGX100? Will you have to change this spec? And it turns out that because in Redfish fabric is recursively defined, and because in our spec a host has a private fabric, effectively a cluster like a DGX A100 can be modeled without modifying the XPI spec. That's one of the learnings since the last time. Okay, we've been doing a lot of review of the data set and the service mesh. As you all remember, the data set really wants to encompass data everywhere, starting from SRAM and HBM, where it might be initially allocated on heaps. And then, I mentioned to you last time that the way most people are using CXL is that they demote and pack at the same time. So they take their allocated application objects, they pack them either page or separate packed objects, and then the packed objects get demoted. And if you are going to have computational memory, you're going to have to figure out how do you compute on that stuff. So there is a notion of unpacked objects, and today we will have some discussion around very efficient packing formats like Arrow, where the unpacking is a zero effort operation. Okay. We also mentioned, and this has become very important, especially after FMS, that if you're going to track data all over the place, and Manoj and TPP team in past have mentioned that mapped files are a key CXL workload. So we need to track memory all the way down to where it's in files. And basic idea of file that we have in XPI is to be compatible with all notions of file that exist in both hyperscale style file systems like ADLS and Google Colossus file system, but also be consistent with high performance file systems like Lustre and GPFS and so on. So, it turns out that the initial proposal is standing good, but I will have some more to say on this today. And then at the very bottom, many machine learning use cases are working against unstructured objects that are maintained in S3. When I talked with people at Microsoft with respect to XPI, their acceleration architects pointed out the importance of companies like VB8 and Milvus, as well as, in learning about Amazon's infrastructure. We are learning how Postgres, for example, or BigQuery, for example, are evolving to incorporate feature store or vector DB features in the database itself. So the notions of file and object need to be consistent with hyperscale and notions that you find in things like Databricks, Pinecone DB, other properties that people brought up in the review process. Okay, so just a reminder quickly again,
hey, Pankaj,
is that
sorry, just understanding question on previous slide. So when we are talking about the CXL memory, you're also assuming that it can be mapped into a file system. So instead of just doing load and store, the CPU will access it as a file, and of course, in the end, it will get access to the file system. Is that the box which you have outlined?
No.
That's what it's referring?
No. Let me explain this here. Okay.
Okay.
So when you have data all over the memory hierarchy, it can go in a tiered hierarchy to places where it cannot be directly computed by the CPU that created it. So we have to be very clear in a tiered system with far memory what can be computed by hosts, what can be computed by devices, and what can be in exposed memory. Like, pre-CXL, it can be in RDMA memory. Post-CXL, it might be in load store accessible far memory. So there, if you take something into a computational memory subsystem, and then you have proper mappings through CXL, it might support some operations like load store and atomic operations, not the full compute, but at least some memory semantic operations can be supported over fabrics like CXL fabrics and RDMA fabrics. So there are three notions of computation. They are all on semantics that are higher than packed object. But some formats like Arrow we are learning might make it so that even you have packed objects or files or archived objects. You can take archived objects in certain classes of file. You can convert them to files that are mappable or cacheable and can be unpacked. And if what you have in files is like Parquet or other Arrow or other friendly formats, then you might be able to do even vector operations locally where the file is located simply by mapping. Or you may have to do unpack before you can do those operations. Okay, so the goal of the XPI stack is to capture this kind of, operability of that data, which is what kind of packing format is it? Is it an open data format like Arrow or CSV or, HDF formats? Or is it a proprietary format that requires additional software to interpret it? Okay, so these are things we try to capture by having data set annotation as well as some service mesh dependencies. Okay, that's the architecture that I walked you through last time. Okay,
so Pankaj, I got it.
Just
last thing. So the reason for my question was, why are we differentiating DRAM memory with CXL memory? Because from the system perspective, it's a big system memory map, and part of it is DRAM and part of it is CXL. That's the portion which, that was the reason for my question. Yeah.
There is no reason to distinguish between one type of DRAM and another. It's mainly intent that is common in tiers. So when people have far memory tiers, we noticed in the architecture at Google, Meta, and Microsoft that people were packing the memory objects to create far memory objects. This was, in any proposal that is trying to aim to do some standard-like activity, we try to capture best practices in the industry, and we noticed this was the existing best practice. It might change, if you have a very low latency interconnect. Okay, so moving quickly along on the review still is that, the basic notion is very similar to any kind of function DAG. And this is already in use at Meta and other places. For example, in some of the at-scale conferences, the Meta architects who describe how Meta places services for whether it should be located at the edge or in the data center core, they already describe their applications as service meshes. So this is very common practice in the industry and in the even in enterprise workloads. The one thing that XPI adds to all this is a very flexible dependency architecture to capture set valued dependencies on a per function basis. These dependencies, like I shared with you last time, might be it's something that says, hey, I am a CUDA function, so I need a CUDA runtime. Or it might be something more sophisticated, like in case of Microsoft CompuCache. It might be I am a CompuCache service, therefore I need a full VM running a database runtime. Or it might be something as simple as I'm an FPGA function that knows I'm a Parquet reader. So all I assume is that there is an open format like Parquet or Arrow that is present, and I don't have any other dependency. So the idea was to have a very flexible notion of dependency. A function can have many parents. That is why it is called set valued dependencies. And today, we will look at some further tagging and examples. In particular, in the area that people brought up on the provider side of the API, they said that, the working memory for these functions is a critical constraint. And in that area, the maturity exists in database literature on tagging functions as either pipeline friendly or pipeline breaking. Similar practice I found in machine learning literature on what are called vertical functions and horizontal functions. So vertical functions that, for example, add two vectors or take a dot product of vectors. They're very memory efficient. You're just doing element by element operations. But if you are assembling, like joining or doing outer product or doing something that, or like cross tabs on database columns, that actually creates a lot of memory pressure. So those are pipeline breaking functions that are called horizontal functions. And there is a lot of literature, both in the Arrow spec in Apache open source, and then also in the database, VRDB, and other conferences that I found, on the basis of which we'll be doing some new ideas in today's session, like function tags. So last time I walked you through this very simple example. This is just to remind you, that whole theory of operations I said can come together in a single sentence. Like, you might have an embedding services mesh that is a subgraph builder, and it can operate on infrastructure accelerator, a sea of accelerator infrastructure that you have configured using similar semantics like you might use at EC2 or GCP or Azure. And it might operate on a sharded parallel graph with specific dependencies like, the ith shard and the ith subgraph builder should be co-located. So this all we went through last time. And this is a reminder for you that, this is where we were when I was here last time. So now I want to, quickly summarize for you guys where we are after the discussions we had. And in the middle column, I've listed, several of you have given me your time. So Pecan, thank you, Durgesh. Thank you for these meetings. And Brian did a one-on-one call, as well as Pecan went so far as to identify two other people who will be from Intel who will be able to work with me on this. I also had meetings with Vidushi about a paper we will discuss for learning. So it's a very important paper that Google published at ISCA. This is about end-to-end accelerators and what are the minimum needs for pairing on-chip and off-chip acceleration. For example, what computational memory will need. I also met with one of the European architects of AMD who works on both FPGA and non-FPGA accelerators, has a lot of experience. I know him from previous SoC workshops, and had extensive meetings with the database community, and in particular with architects at Voltron Data, who is the keeper of Apache Arrow format and things like, if you break off query plans from databases, there are variants of Arrow format called Substrate that are used for carrying that database plan fragment to the device in an open and vector-friendly format. So there's a lot of development in the open community, and they gave me a lot of time. We had a workshop at UCSC called Computational I/O Workshop, where many of the active people in the database acceleration community came, and we had good discussions, and a lot of learnings today are from my UCSC work as well. And then, through conferences such as the review work that is going on for SOSP and memory-related workshops like DIMES that are going to be held there, we learned about this kind of literature. I was mentioning to you that there's a lot of work now for several years in database community. I asked you, when I share my PDF today, you will have a link in there, but I just included the full citation. You can read, starting with this paper, how database community is formalizing the operators that they send to computational memory and computational devices, including, another server like a shuffle offload server in Google BigQuery does. Okay, so for this, we are introducing today in service mesh this new notion called function tags. And like I mentioned, these tags, they identify each function as either pipeline friendly or pipeline breaking, per the examples I gave quickly earlier. And many of these database operations actually come with a parameter called chunk size. Using chunk size, you can control for a given instantiation how much memory footprint that will take. So if your offload engine has a lot of memory pressure, you will be able to control through chunk size selection whether it will be more oriented toward taking big chunks of data and having higher throughput, or the accelerator will be shared primarily for working memory with other accelerators, therefore operate with a little bit higher setup and tear down overhead with low chunk size. Okay, so this kind of work is going on. I wanted to give you both a business flavor about who all are interested and starting to work with me, and the kind of flavor of work that is going on. And I have a little bit more on this that will take 5 minutes. Okay, so basic plan I want to share quickly is that we think we are at version 0.2 right now in terms of the formal document and examples. We want to, by end of this month, actually complete a modified example with these new function tags and modifications that I will summarize on the next page, such as new data set tags that are formalized. And we want to keep making progress on meeting some of the objectives of very high degree of pipeline by defining interfaces that can be issued simultaneously from many nodes. So one of the problems that CXL has inherited from PCI, and also Python data science programmers work differently from HPC and ML programmers. So the mindset is single rooted. And to get the industry to use CXL, CXL3 and its parallelism properly, like device-to-device communication, we need to embrace things that are already present in high-end frameworks like NVIDIA Collective Communication Library or HPC frameworks, which is you run same code everywhere and simultaneously in many places, and you call the accelerator functions from everywhere all at once. This is not common in like SNIA and NVMe specs for computational storage. So that mindset change will require a little bit more work in the API so that the APIs look more like high performance APIs such as you find in CUDA and less like the low performance, command heavy and communication poor APIs that you find in SNIA and NVMe specs, for example. That's not a personal criticism. It's just that those specs are coming from storage and they don't have the right kind of thing for memory. So anyway, we are having this meeting right now, and we'll get a little bit into sort of fabric scale accelerator chaining. But we need more discussion on inter-device parallelism. We need to make sure the progress is visible for pipelining and steering, especially pipelining across accelerator and host on the one end and devices on the other. Okay. So there is going to be a concurrent activity on computational storage side also that I'm doing with Hynix and Samsung people who are active in the DCI group. On OCP Summit, there is going to be a session on October 18th from 2:30 to 3:30 where I'll be talking, and later there will also be a panel. And this is with sort of customers who are using this kind of thing as well as with vendors. I want to take a couple of minutes to give you a quick flavor for why we are doing what we are doing. Okay, so I mentioned the ISCA paper, and what I've done here is quickly summarized for your understanding what is the difference between chained accelerators and unchained accelerators. So when you do traditional, interfaces to offloading today, you are very much wasting a lot of time in setup, like supplying parameters and copying parameters. You're triggering functions, and then you're picking up the results. I'm not saying everybody does this. There is a lot of streaming accelerator offload, for example, in CUDA. But in OpenCL and some other places, I found this to be widespread practice. So Google in particular have modeled this kind of benefit especially when you start to need a lot of different accelerator types. And they have defined this idea as a sea of accelerators. I encourage everyone to read this paper. Chaining and balancing of these pipelines, low setup time, and hardware-software co-design approach, and creating a situation in which the functions to be offloaded and their dependencies are explicitly made available through the API. These are the key requirements that Google has identified. Durgesh, you look like you have a question or comment.
No, I'm okay.
Okay. So, this was one thing, and I'm not going to go through this slide, but in the paper you will read why, if you don't do all this, then things don't work. The other thing, important idea that we are pushing in XPI is that you should expose parallelism. And I'm very data driven. I'm not trying to be idea driven in API development. So what I'm trying to do is take best practices. And I found a really nice paper from Georgia Tech that explains what benefit do you get, like an order of magnitude benefit you get if you try to do APIs in which parallelism of device and inter-device communication. So think about, cloud sort. So suppose you are running BigQuery, you want to do a shuffle offload or sort offload. There are two ways to do it. One is that, you think that all the data is going to be communicated into the interface by one single rooted host, and then there is going to be a pool of devices. The other idea realizes that sort might be happening with 10,000 cloud nodes already active. They all have sharded data. They all call into the sort at the same time. The devices go to work, and then they come back in a parallel computation with a parallel output that is given to the individual shards. So the thing that this paper points out is that if you do it the parallel exposed way, then you are an order of magnitude faster than if you do parallelism hidden way. And again, I invite you to read this paper. I will have the slides available at the end of the meeting today. Okay. The final thing that I mentioned to you, we are looking at Arrow. So this is explained a lot in Arrow's Apache documentation. But basic idea is that without Arrow, there is a lot of copy and conversion overheads between host format and device format. And there is also a lot of serialization, deserialization. So much so that all benefits of acceleration can be lost. So in XPI, we are embracing, the best of breed open source activity, which in this case is Arrow. And Arrow is a whole family of stacks. So, we are running out of time quickly. I will just tell you, this is the last slide. In this slide, I have summarized everything I mentioned to you quickly today. And I invite you to come back and participate in discussion. So I mentioned to you, these are the 4 activities we are doing. This time I've come back to you with adopter considerations and use cases and what changes we are making. We still have API technical work on parallelism and progress visibility and steering that we need to do. And then after that, we still need to get into provider considerations and testing 2 kinds of optimizations, which is above the line manual optimization, where the API user decides function and data placement very manually, and below the line optimization, where the API provider provides a lot of automatic data placement and optimization. So I invite you to contact me. Manoj said he will set up a subgroup where we can have formal discussions, and Manoj, control back to you. It's 10 o'clock. Okay. You're on mute, Manoj.
Hi. Hey, thanks, Pankaj. I think this is awesome. I think we do need to spend a lot of time on and have a separate work stream on it. And I'm hoping actually companies. I know we have a lot of hardware contribution participation here, and there are a lot of software folks also joining. But this gets into the applications and then people who are using these underlying libraries. So if you think this requires us to get right people invited into this meeting, please let me or Pankaj know so that they can, right people are there contributing into Pankaj, the work that Pankaj has been driving here. I know that we had contributions from participation from Memverge. I'm not sure if anybody's here today, but somebody like Memverge, etc., should definitely participate and provide valuable inputs in this. So Pankaj, we'll figure out. I think once I get the Zoom done, I think we should be able to allow you to have a Zoom call set up so that people can join into those meetings also. With that, thanks, Pankaj, for putting this and driving this. I know this is a lot of thankless work, but I appreciate that.
Sorry, I dropped Manoj. Yeah.
Okay. All right. Let's see you guys next week, and then hopefully by that time we will have white papers almost published.
Yes. All right. Thanks, everyone. Bye.
Yeah, thanks.